Um, Also, I don't know if this is premature, but I did get a DX engineering update to the group
Hmm.
chat. So maybe the W80DU towers are soon to be on the air again. I can probably remove this one. And Dr. Frizzell also put together a ham site drive photo. So I've
Hmm.
linked if wants to check it out. Okay. John, any updates on, or I suppose Bob, if Bob is around, any updates on the Grape 1 deployment?
Bob is traveling back to Massachusetts today, so he will not be on. Um, I really have no updates, and Kung has been doing some work. I'm not sure if he's on, but he'd probably be the only one that would have anything.
Would you like me to talk to Zorman perhaps about the process for reimbursement and shipping and everything?
Yes, that would be helpful.
Okay.
I also have my summer student starting today, and he just walked in, so I'm going to be
Ooh,
hopping out here. So,
exciting.
yeah.
Actually, before you go, are there any updates Grape 2 wise? If not, I'll let Punk handle
None
it.
that I'm aware of. No, I haven't really. There haven't been much on that. We've been pushing on some firmware issues, and but nothing of. I mean, we got the plotting working now. It's producing the daily plots and the magnetometer plots in two different forms. So,
Okay. Because Kong's not on either, so I suppose that will just be another thing
yeah.
we don't necessarily have to talk a lot about. Okay.
Yeah, I'm going to step aside for where I'll be back, but
Any update on the Grape 2 Eclipse data? That's also a Kong thing, and I don't think he's on the call.
yeah, we haven't figured out where we're sending it yet. So that's really what we're waiting for.
Yeah, I think the DRF stuff is going to the Alabama site.
Right. But
Yeah, that's in the
there,
work.
Yeah.
he's
Yeah, I actually let me see. I actually did get part of it working. It's just that at the moment it takes a very, very, very long time. Let me see.
a lot of data.
Yes, it takes a lot of data. I think I let it. I started this conversion process. I developed like a preliminary version of this conversion program. Let it to run. I said running at 4 a.m. I believe. It's still running.
Oh my gosh.
Uh,
How much data?
for one day.
Okay.
Try to convert one day the April 8th eclipse for the W2 NAF station. And it got 23 hours done. One more to convert. So I decided to actually develop two different programs actually. So one of them is gonna be a CSV to DRF um program to convert the existing CSV files into DRF. And this program we will prioritize code simplicity. Um, so I'm probably gonna use Python for this. But the other one, the other set of program, it's actually not gonna be a program. It's gonna be a set of routines because these will be integrated directly into the running Grape2 system. Instead of doing conversion, it actually will take the raw data and directly write it into DRF. So completely bypassing the CSV. It will be a lot more efficient and a lot more efficient, obviously. So it's gonna be written in C. So that would take a longer time. Uh, So right now, what I have working is the CSV 2DRF program. So this is the one that's gonna take a long time to execute, but
Yeah,
I
you've
have it
got
running because I
6 hours of processing and you got 24, so it's about 15
yeah.
per hour. Yeah.
I mean it's only like a draft version at the moment. I'm sure there are a lot of room to improve. Yeah, that the difference between the Grep 2 data versus the Grep 1 and the RX-888 is just that one bandwidth, and that makes all the difference.
Mm-hmm.
Like 800 times difference in the size. And
Yeah.
there are actually some caveats with this conversion. So the CSV files, each hour has its own metadata. But right now, for the data we have on the Alabama server, we have one metadata for the entire day. It is possible in digital RF to have metadata for each hour, but it seems like that's just not what we are doing at the moment. So to maintain consistency within a single day, I decided that if any of these, like I call it critical properties, were to change during that day, conversion for that day will be aborted. So these properties include changing of the beacons being decoded, the
Mm-hmm.
gain, the antenna, if the
Right.
grid position moved or the sampling rate changed. If those things change, conversion would not happen for that day. It would just be aborted.
That makes
Nothing
sense.
will be deleted, but it just not
Right.
gonna happen.
Right.
Um and data
Is it,
block with failed checksum will have to be ignored because there's no way for me to save data and also say that okay, this data failed with the
Mhm.
checksum with the DRF, unfortunately.
Yeah, it's a weakness of the DRF. Are we planning on, because I know Nathaniel's been talking about doing the 500, 600 hertz decode of WWV and WWVH, but the metadata the DRF is using now is only 10 hertz wide, which means it won't support that. Are we planning on switching over to that, or maybe Bill can fill us in on what's going on with that?
Well, there's a couple things. The amount of metadata you carry in DRF is programmable. You can make it, you can have metadata for every observation if you want. I mean, there's no limit on how much metadata you put out there. So you can, I mean, if you want to, you could store metadata. It'll bulk up the file quite a bit, but you could store metadata on a more frequent basis if there's any need for that. I set it up one meta file per day because that an observation is one observation at a given rate of a given frequency, and it doesn't make sense to mix them. But anyway, that's something we can talk about depending upon the requirements.
Yeah,
I answer the question.
I just thought that I will abort the conversion because I think the plotting programs right now are just grabbing the whole day and just process that data. So if like the gain changed during the middle of the day, that
Yeah,
plot wouldn't be appropriate anymore.
yeah, it should be a very infrequent happening, but yeah, but if you do change a parameter like that, it kind of does screw things up. So
Yeah.
that makes perfect sense.
Yeah, I would agree with that. Yes.
And the other thing is because of this the file size, uh right now the DRF on the server is actually saved in saving IQ data, but our output is actually real value data. So I actually asked it to do the conversion on the server instead of on these pies, or he actually agreed to look into that, which would be a great help, and it would take a lot of weight off the pies because that
Mhm.
conversion from real to complex is actually another big task on its own.
Yeah.
Well, one thing we're going to have to figure out how to deal with the issue of compression. If there's a way we could do lossless compression before the upload, that will save bandwidth on the upload.
Mm-hmm. Well, it's less of the bandwidth upload. It's more of the computing power here. We are quite at the limit right now. Just this conversion program just take up like a whole core here, and just loading. So to apply the Hilbert transform to go from real to complex, I'm gonna have to load into the whole day. I can do the conversion, the data conversion piecewise, say per hour, but I feel like that's gonna create edge, like edge effects between between the between each hour. So I'm pretty sure it's gonna be best to apply the transform to the entire day, but loading an entire day of data into memory, that's going to take up like 7 GB of RAM, and the Pi just does not have that
And it also shut down
capacity.
our collection stuff, so we have to be careful about overrunning the bandwidth of the thing, because that's definitely going to push it over the edge.
Yeah, I try writing the code for that, and the practice says like I can't allocate enough memory. It's just
Yeah, they're only 8 GB to start with, so yeah. And we're using up a fair amount of that with just the Grape 2 data collection stuff. So
So
yeah.
I myself don't have experience with doing the real to IQ conversion. It's going to have to be something written in C++, I expect. So I'm going to be looking for help on that. Maybe Franco or somebody on that side of the team may be able to, but it would be well, there's no way I'm going to get that done in the next year. So
that's a heavy lift. That's definitely a heavy lift.
I'm a little confused. What are we trying to do here? Take Doppler data and convert it to DRF?
Yeah, the data coming out of the Grape 2 is just all real numbers. It's just A to D values. And the way it's stored in DRF is IQ. So something has to convert it from real into
There's
IQ.
no Q.
Well, you run it through the same thing I can do this using GNU radio. Same thing we do on the Grape 1 to convert the sound data into IQ data.
Oh, so you're shifting it?
Yeah, I mean that's what you need to do to get the spectrum.
Okay. So Grape 2 is not sending Doppler data, it's actually spectral. I mean,
No,
it's a
no,
real
no.
waveform.
What Grape 2 is collecting an 8 kilohertz sample and storing it in a raw file, and then we are using the FLDigi algorithm to create the 1 second epochs of frequency estimation, and that's what's being sent. But we're storing the full 8 kilohertz bandwidth data on the hard drive.
Oh, I see. And that's what you're trying to
That's what we're trying to
transfer.
convert to IQ data. That's
Can you
about
do
10
the
gig a day.
Well,
conversion?
why aren't you just uploading that data?
Because it's not compatible with digital RF.
Well, it looks like we're going to be uploading that data to the server, and then it's got to be converted into IQ to store to be compatible with everything else. All the plotting software, everything assumes IQ data.
But you're converting it to a 0IF, is that it?
All it says, I guess that's the right terminology for it. I'm no signal processing expert.
Right.
So-
But John, what is it? You're taking this, what are you sampling at 8 kilohertz? The
I'm
1
sampling
kilohertz carrier?
the 1 kilo, the output from the Grape 1 radio or Grape 2 radio is the low IF 1 kilohertz, and we're sampling that at 8 kilohertz. Soon to be 8192, but yeah, right now we're doing 8 kilohertz.
Right.
So the data has to be converted over. Why does it have to be done on a Raspberry Pi? Can't you do it on a bigger machine?
I don't
Something
think
that's
we have the
faster?
bandwidth to do it on a Raspberry Pi because Kung just said he was doing it for the last 6.5 hours and he's like,
That's what I'm saying. Can't you dump the files? I mean, you have to transfer the file and it's a big file to transfer via internet, but the crunching could be done on something that's much faster than a Pi.
that
Well,
looks like the gig
We've been talking
informer.
about doing just that.
Yeah,
Yeah.
It's just,
So
that-
upload the 8 kilohertz data
but
and
that's
then have a
over,
server that does the conversion.
right. But the problem is the 8 kilohertz data, it's about over 10 gigabytes per day, which is a heavy lift on some people's internet connection.
Right.
yeah, unless you have a very fat pipe, you're not gonna get everything uploaded in a given day.
Yeah.
Yeah, I know. Well,
I'm very
being on
spoiled. I've got gigabyte
Comcast
fiber to the house.
Xfinity, I'm that way.
Yeah,
They
I'm
keep
gonna run a-
up, but it's still pretty meager.
maybe
Yeah,
we have
I'm
to tell everybody, you have to have wide bandwidth internet connection to participate in the project or put in the Starlink system. You can do it that way. I mean,
You
Yeah.
know,
there's gotta be
I've
somebody.
got, currently I have 20 megabit upload.
There's got to be some way we could do some conversion on the Raspberry Pi before uploading. I mean, I should say compression, not conversion.
So, well,
Some compression.
what's the sample rate that you're converting to in DRF?
The same sample rate as was recorded.
Well, then you're doubling your data, not reducing it.
Oh, I don't care how much space it takes up on the server. I'm just concerned about how much it takes to do the upload right now.
Well, that's what I'm saying, that if you're converting to IQ at 8 kilohertz, you're getting two words per sample instead of one.
Right.
But we're
You
doing
might
that
as
on the
well
server.
upload the raw data.
We
Yeah.
upload the raw data, and then we do all the conversion to IQ on the server. But the
Right.
point is, I'm thinking we need to be able to do some compression even before the upload on the raw
Well,
data.
that would be the thing to look at. If we can do lossless compression, you might get a 2-to-1 reduction.
We found that
Right.
we get about an 89% reduction, or
Oh.
89% of what we had. So it's about a 10% reduction with the compression we tried.
Yeah, okay, because
Now
it's
there is
pretty
one more
noisy.
trick we're going to play, and we didn't have time to do it before the eclipse, is that if we convert to storing in binary, we cut the data set in half. So we can cut our 10 gig down to 5 gig.
What's it being stored in?
Binary. Right now it's being stored as ASCII characters.
Oh, well, there you go. No, it
Oh
should
yeah,
be binary.
we just didn't have the time to make it work. And the other problem
mean,
that Kung
WAV
ran
files are
into
binary.
is the when you have a power failure and it comes back up, the data stream and the file gets corrupted with null characters, which is extremely easy to fix in ASCII data and next to impossible to fix in binary data, because binary you will have zeros, where in ASCII you will not. So we've still got to figure that problem out, because we ran into that on one station. One of the days was corrupted, or one of the hours was corrupted by a power failure. Which is what I'm
Yeah.
doing on Grape 1, I'm already doing that. But again, it's all ASCII data.
Yeah,
We
if you
got some hurdles
do
to jump here, but we'll get there. But
Yeah. Well, if you did signed data, you could detect that you had long strings of zeros.
let's see, the data coming out of the A to D is unsigned. But yeah, like I said, there's
Anyway.
different things we can play with, but this is probably not the appropriate time to talk about it. It's a work in progress.
Yeah, but a point I'm trying to make is don't convert it to IQ before uploading,
Yeah.
because you're just going to double your data.
Yeah. Well, even a 5 gig lift for a lot of the people is going to be a game stopper. So I'm going to have
Yeah,
to
and
send
then
a message of warning people that, once we start doing this, we're going to start using some bandwidth.
yeah, and running ASCII is not that much of an overhead if you do it right. It's only if it's actually binary data with the ASCII stop bits around it. It's like a 20%.
Well, it's ASCII
Penalty.
characters. It's not the serial protocol. It's the characters are storing it as ASCII instead of binary.
Just asking numbers? Or are you
ASCII.
using the whole 8 bits?
Using the whole 8 bits.
Right.
Well, 16 actually. So it'd be
Yeah, it's 2 ASCII characters per sample.
no, it's 4 because you have a full byte. Each byte has 2 characters.
Well, there's the other thing you can do. You can have it ASCII characters, but they're not actual characters. It's binary data in the ASCII
Yeah,
frame.
you can do that too.
That gives you
What it's coming out of the
2x
data deed is
improvement.
actually a 16-bit raw
right.
binary
I
number.
understand that. It's coming
that's
in
what we're
16
planning.
bits raw, but you can encode that in 2 ASCII characters, not 4.
Yeah. But the plan is to go to the full binary. Anyway.
Yep.
Moving on.
Yeah.
I'll
The
just
data-
point out that we've done data transmission over ASCII that way, so that it's 8-bit chunks of the data
Mhm.
rather than 4 bits.
Since the data's already been collected, though, I think that can just be worked out when
Right.
one looks into what's best for the
Well,
conversion.
you're talking about how to upload it. And
Doing.
there are changes involved, so.
A work in progress.
Thank you, Co.
I actually have some good news.
Oh, sure.
I think the conversion process finished, and it reported a final size of 3.2 gigabytes
Oh, wow.
with the lowest level of compression as well, because DRF has this built-in compressing ability, and there are 9 different levels. I set it to 1 just to try out this process and not put any like too much weight on the computing of the Raspberry Pi. So I didn't expect that much compression at all, but it returned a final size of 3.2 gigabytes, which is actually a
Starting
lot
from
better than
the
the
10.
starting point of like 10. Yeah.
Yeah, DRF, I discovered this early on. DRF, even at compression level 1, gets you about something on the order of 60% compression.
That's what we're seeing.
So
It's just we got to get around that 6-hour compute time.
yeah,
Minor problem.
And watch
I'm-
out, different
yes.
signals will give different compression, because if you
Yeah.
get a lot of spread F,
Mhm.
it may not compress very well.
Yeah.
Okay. Either way, thank you, Co. The fact that it works at all, I feel like, is amazing
Yeah, that's a
I'm-
huge accomplishment.
for data. So
You get to go home early tonight, Kum.
It's magic.
And get some ice cream, by the way. You deserve it.
Oh yeah.
I want you to get something for yourself. Real nice.
Thank you.
Okay. I think unless there are any updates from Gary or Bill on the website, we can probably move on to the comment section.
Just one little piece of news.
Sure.
As you might recall, I had anticipated that during field day weekend, the uploads would fail because of the university simulated emergency test. But somehow or another, all the uploads work. So apparently they left those servers online during the SET. The website wasn't available, but all the data was there. So nobody has to worry about re-uploading or doing anything. No recovery is needed. So
Oh, that's fantastic news. Yeah.
All right. Thank you, Bill. I think at this point, we'll just move on to a little bit of an open forum and comments on the impacts of the kind of infamous now May geomagnetic storm.
I just took a look at the GSK reported data, and there's a huge dropout that doesn't really sort of recover until the beginning of the 12th.
Wow.
Yeah,
Yeah, that was true. I was seeing that the ionosphere got really energized for a long time, the absorption.
Yeah, my data, I think I sent out a snapshot on the 11th, and all 3 bands were just like dead.
Yeah,
May I show
Philip
my
says the 12th was still very dead.
may I show my CHU reception graph for the 11th?
Absolutely.
Let's see. It is this one. For those who know the hunting of the snark, this is rather like the the chart of the sea that the crew so lauded their captain for distributing. Here's the next day. Yeah, so that was okay. That's all I have to say about it.
Snow White without the 7 dwarfs.
Yeah. Yeah. Do folks need a recitation here of the hunting of the snark and the description of the ocean chart?
Go for
No,
it.
we're all familiar with our Lewis Carroll. Very good. Okay, carry on.
Let's see.
Yeah, it might be worth pointing out to the FCC that the event continued past the 11th.
Oh yeah.
Well, I think at the moment they're mostly
I'm reminded of when there were atmospheric tests, nuclear tests being happen. I think one of them wiped out HF propagation for a week.
Oh my gosh.
they seem to be primarily interested in the distortion of the propagation of radio frequency waves. So that does seem right up our alley.
Yes, that does.
Obliteration is probably more the appropriate
During-
term.
Copy this section in. Of what they are more specifically looking for. Oh, we'll put that. Oops. So they are really interested in whatever graphs, evidence, recorded data we have from that time, and some comments on things, probably to give them context.
I put a
think we
link.
can-
I put a link into the chat to some charts that Gwen G3ZIL has presented about that event that could be presented to the FCC, and they're even interactive, so you can move around on them. But they show various things in terms of spot counts and background noise levels and so on.
Is that the Grafana login?
Yeah, yeah. These are you don't. Let's see. Oh yes, you would need to probably requires a login.
Yeah.
Yeah, I can give you the here. I'll give you the login. WD read is the login. Whoops. Spell check. And the password is
What was the username?
WD read. It's in the chat. I'm putting it
okay.
in. Yeah.
Got it.
Yeah, we would probably want to.
You can put the
Or-
the login and password into the minutes if you want.
Are you sure?
Yeah, it's okay. It's a read only. It's we just didn't want to have trolls out there, but any one of you is welcome. There's
Well, this
a
post
wealth of pages, not just the FCC's. There's 100 different graphoneage pages there.
these are posted on YouTube. The
It's
minutes.
okay. I think it's, well, keep it in the chat then, maybe.
I have it.
Yeah. Yeah, if it's on.
Let's see.
There's some specific place on this site now that I'm in that you're supposed to go to.
Yeah, one of the things you'll notice that the KPH, there's a glitch in the middle of the day on Saturday, because they go out there and turn on the fluorescent lights for the visitors, and it raises the noise level for 10 dB. So Saturday afternoons, unfortunately, the event occurred on it persisted through a Saturday afternoon, and we ended up having a glitch of noise. So that somewhat interferes with the
Where on the site are we supposed to go to see this?
FCC. It's noise graphs.
Oh.
CH. Here, I can show you if you
Got
share.
it. Got it.
And you can look at other sites. There's you could pick, we picked the KPH because it's probably the quietest site we have certainly in the Western US. So the noise level variations are clear. You can see 20 dB background noise level variations on 40 meters diurnally. So I don't know that there's any site that really approaches that. That's our basic index of how good a site is. And I don't think you can get this kind of data from Grape receivers, but the AAA sites, you can get this background noise level measurement. It's logged to our Whisper Daemon database. So it's easy to look at different sites and see how good a job they are. To what extent is the site actually looking at signals from the ionosphere versus locally or internally generated noise.
Actually, with my mag loop antenna, I've had a noise floor of minus 180 dB.
I don't think that would be a KT. It sounds like you've got a cryogenically cooled antenna.
Well, it's the fact that FLDigi is doing an RMS of the background is why it got that low. It's physically not possible, but
What
the
size
numbers-
loop are you using, John?
It's the DX Engineering. It's about a 1 meter loop. I think it's
1 meter, okay.
2 turns.
Yeah.
Oh,
If
and
any-
2 turns, okay. Yeah,
And
I've
got
got
a,
1 and
I've got a nice
1.3
preamp
meter.
that works with that, by the way, if anybody's interested.
Yes.
Yeah. Anyway, you should note that shelf in the middle of on Saturday, the noise jumps up and stays at minus 136 for the 8 hours that visitors are welcomed into the radio station.
What are some lights?
And so when they close the station, then the fluorescent noise level goes away, and the KPH isn't really focused on the people there aren't focused on radio science, and so this isn't a big issue for them.
Right.
The noise isn't a big issue. They're not unresponsive. In fact, I'm going to go and talk to them about it on Saturday. See if we couldn't do a little project out there.
They give them some different DC lights.
So John, are you saying you have a loop preamp that you've designed?
Yes, I had sponsored it as a senior project, and we compared it to the DX Engineering one, and it actually worked a little bit better.
Yeah, I'd be interested in looking at that.
Okay, it's real simple.
Yeah,
Yeah.
can you send that email?
Yeah.
Yeah.
Yeah, it's my understanding that no loop antenna or any active antenna with a short, a relatively short aperture, none of them are able to record the background ionospheric noise above about 10 megahertz. That the internally generated noise of the LNA will dominate above those frequencies. So this is, I mean, at 40 meters, there's enough atmospheric noise that the loops work great. But if you wanted to look at 15 or 10 meter noise, you're going to be looking mostly at your LNA's internally generated noise. So that's I mean, this is, KPH has a 100-foot tall PCI 530 log periodic.
Oh my gosh.
Well, yeah.
Yeah.
So, so and we have worked through the the RF distribution chain to ensure that you can, I don't know if we go,
Yeah.
let's see, I don't know what that, let me
Of
see
course, the
what.
problem with that, it's got a sharp beam. You're only looking one direction.
No, it's an omnidirectional, horizontally polarized omnidirectional, TCI 530. It's used for, medium distance communications. It's 3 to 30. It's not, not very high gain. It's, I don't know, 6 or 8 dBi. And the antenna is actually directed at about 45 degrees off of vertical. But it was installed to talk with ships out at sea. At KFS, we have big log periodic wires that are directional, and have one of them has 16 dBi gain. This is the TCI 540. 400-foot on a 200-foot tower, 400-foot wire log periodic. Pretty amazing antennas. That I have charts there, but that site has a cell phone relay sites there, and so the background noise level is a little higher, and there's some switching power supply noise that comes in from. Anyway, if you want to, you can go to that site. If you log into Gwen's page, you can just change and go to different bands, select 20 meters, and you can see that there was a different noise profile, as you would expect. And all of them, even at the higher frequency, you can see more clearly the fluorescent noise on Saturday afternoon. It really stands out. I don't know, I could share the screen if you want to see it, but
Sure.
this is so if you go to that page, so you can see here's Saturday afternoon. This is 20 meters background noise. So it's and we go to I don't know if the bands were even open on 10 meters. Go up to 10 meters, almost. You see a little bump, but yeah, you can see the fluorescent noise. We measure noise in 2 different ways. We do the whisper demon sites measure noise, both in the gap, the whisper gap, the 10 seconds, at the end of each whisper cycle, get an RMS noise level. And then we also do the frequency domain, take the bins out of the whisper D, they're, I don't know, 1 hertz apart or something, and look for the frequency bins across the whole 2-minute whisper cycle and find the lowest set of those and use those. So typically those, we've tried to calibrate it so those under good situations, those 2 noise graphs deliver the same noise level, but you can see here on 10 meters it's different. But if you go down, this is the 40-meter chart. Yeah, so you can see here's the fluorescent noise coming in here, and I don't know if we go to 30. Let's see what 30 looks like. Now, these things will be perturbed. The RMS noises in particular can be perturbed by, CW signals and, various other things that are continuous noise that occurs during the gap, in the region of the. But anyway, once again, you can see the diurnal noise variation on 30 meters is goes down as low as what minus 145 and to minus 129. That's 15 plus dB of diurnal noise variation. You won't see this at many sites, but you can go. There's a whole list of different receive sites. You can go to any one of these. Here's I'll show you not a very good site. This is Nathaniel's noise levels. Yeah, so you take a look at his noise level at 40 meters, and you can see his diurnal variation. So I think he turns on his air conditioner or something in the morning, and he gets a big burst of noise in the morning. But anyway, you can see there's there's, he's got about 6 or 7 dB of variation. So that gives you an index of the quality of performances of Nathaniel's site. I was going to work with him to see if we can improve that. There's no reason why he couldn't be doing a lot better than that. Anyway, I'm sorry. I'll just give you an idea of what you could find if you looked around it.
Just so you know, Rob, I'm actually very interested in this aspect as we're looking to deploy rheometers that are basically looking at the galactic noise.
Well, we were able to actually observe this galactic noise at KPH and 15 meters and determine, because we could see a noise peak off that TCI 530 that was
Right. Well,
diurnal.
Or
We
a
could, and there's a
230-foot antenna.
well, this is the 100-foot tall Omni, and it
Bill.
and we would see a 2 or 3 dB peak in the background noise level. It would track the sidereal motion of the galactic center. So
Right.
there's a report about how we established it. Pretty certainly that KPH is able to listen for that, and not that and we haven't optimized the site to track that, but we were able to see it in the noise level. There's a report on this that Gwen generated several years ago that he is published on our whisperdemon.org. So if you're interested, all of these, the core of this is a message here is if you want to measure noise, you need to be looking at these background noise levels and see the diurnal variation. That's the single best index of a good receive site is the in essence think of the ionosphere as a calibrated signal generator, and that changes day to day, but it's up there all the time, and all of us are receiving this. And if we do not see the changes that day to night changes, then we're not looking at the ionospheric noise. We're looking at other things. So KPH is kind of the reference for all this. You should go look at that, ignore Saturday afternoons and look at it, and you will see what is possible, what a good site with a good antenna is possible. And unfortunately, it seems like this is something that isn't recorded or easily recorded at Grape sites. So you don't really know what the noise level characteristics are of the site. So it's one of the advantages of the 888 Grape, the Whisper Demon Grape, is that it will generate these noise graphs, and you can study them for your site and understand how good your whole receive system is. That without this kind of background, this kind of information, you don't really know to what extent the noise part of your measurements, to what extent that it's due to the ionosphere. If you want to look at the ionosphere, you have to, this diurnal variation is key.
Well,
Anyway,
it's not the ionosphere making the noise. It's
it's
galactic noise.
There's above the MVUF, it's galactic noise, and below the MUF, it's ionospheric noise. It's thunderstorms being, there's all kinds of sources that are being reflected and arriving, and to the extent that you're seeing those, then you're looking at signals that are coming. The limit of your receive sensitivity is your ability to detect all of that noise is coming in below the MUF, and above that, then it's a difference. Yeah, above the MUF, it's different. And when we did these measurements of the galactic noise for sidereal noise, we were looking at it was several years ago when the sun's 20 megahertz was above the MUF, so we could see the ionosphere wasn't impeding it. I don't know. Yeah, you have to go higher now. 10 meters or something most days in order to see it. We haven't really worked. We didn't get a lot of interest in it at the time. So, but there's a report there. So anyway, there you are. If anything, that's yes, good. I'm glad you want to point that out. So if anybody looks at the data, they understand that there is a period of corruption. Okay, well.
Yeah, I think all of that's beautiful. I will also point out that the grape data we have for around then
Yeah.
is cool. The 10th is very cool, and you see everything kind of just go crazy on the 11th, which is, I think, the period that I'm very interested in. Make this smaller so it stacks. And our power levels around the 11th. When everything goes a tad crazy. So I think that's kind of the thing that they're looking for. So let me go back.
Yeah, I mean, I could show you his other, he has a count of whisper spots page. If you log on, you can look around at that. He created a series, Gwen created a series of graphs. We were just, a lot of the data comes from, the KPH data is available. There's some measurements of propagation path information that comes from a particular transmitter from Paul Elliott, who makes the whisper sound. His transmit, well, there's a whisper sound recording in there, so.
Okay. I think at this point, so Frizzell asked that we kind of put together a presentation. I think that is Frizzell speak for accumulate graphs and things to be sent along to him. Because I presume he would like to just file one large report.
I'm sorry, were you asking me a question? I just didn't.
No, I was just kind of
Oh.
stating.
Oh, okay. I'm sorry, my hearing isn't the best, so.
Hey, you're fine. Because all of this, I assume, will be passed along to the FCC for sale, but I'll talk to him about it.
Yeah. Well, we could contribute it directly, but I thought it would be, might be more impactful for the FCC to get the data through a HAMSI, so.
Yeah, I might ask him a follow-up of whether or not, because I think he mostly just wants an accumulation of data, and then I assume that he willing to support or submit it, but I'll send him a follow-up email. But for now, I think this is good. All right. Thank you. Does anyone have anything else that they'd like to add or comment? Okay. We could end a little bit early in a shocking turn of events.
Rachel, I have a question. What program do you use to make all those or capture all those screen grabs that you do?
Like Window S. Oh wait, or Window now that I've thought about it, I just use the grabbing tool on my computer. Now that I've thought about the keyboard shortcut that I've used, I suddenly can't remember. It's keyboard shift. It's the Windows Shift S that just does snapshots.
Okay.
They're not really high quality images for the minutes. It's just to kind of get an idea of what we were talking about showing off. So you have
Snap. It's called Snap. If you key in your little search box there and just key in Snap, it should come up.
Yeah. But if you guys have higher quality images that you'd like to send along to either me or Dr. Frizzell, I think that would be very helpful. Just because these are more screen grabs, which means that they don't scale very well if you blow them up or if you put them in a scientific paper or something. They're not very nice to look at. So I'll probably regenerate some of the Grape images for data.
Okay, thank you.
Hey, Rob, did you want to mention the meeting on Tuesday?
Oh yes, we did. Well, you could describe it. We did meet with the Christine's propagation WWB modulation group and discussed the opportunity to install whisper sondes at both WWV and WWVH. We could use those as a way to complement the measurements made from the WWV carrier, and maybe extend the measurements in different dimensions that you can't do, measurements you can't do with a single continuous carrier. So they seemed quite receptive. I was impressed by by their willingness to do this, and I think we're going to move forward. Probably we won't need to wait for the DAISY 2 grant approval or the beginning of it. Paul is ready to, and I have whisper sounds available, and so perhaps by later this summer, after July, we can send them a kit. They both seemed willing to do the installation on their own. I mean, Dave, you'd certainly be there for the WWV installation, and I could send you this whisper sonde and an end-fed antenna that I have, if at any time. I mean, they're sitting here unused. So
I think one of the things we still have to figure out, because the funding is not there, there's certainly going to be ancillary expenses that I personally cannot absorb those at this point.
I don't know what the other costs are. I certainly do, we've got the hardware. We can
there's a lot of things that add up pretty fast. I mean, all working on this project, on the Grape project, have invested, personal money into things too. And it just, if we're going to do it, it would be good to try to make sure we cover the cost somehow, and the grant would be the way to do it. We could certainly get started experimenting and looking at, where you would put things, both here and on Kauai. So,
well,
but there's restrictions that we have to get around. You definitely have to have GPS pucks sitting outside receiving satellites, and those are typically 3-meter long wires. So I don't know if you can extend those, or
you can I use satellite satellite RG6 to extend my GPS antennas at KPH 100 feet. You actually get better signal strength, even though there's about 50, I don't know, there's 8 dB of loss in the RG6. Yeah, even that 8 dB is more than compensated for by putting the puck up in a good location. So,
right. But I mean, so there's a lot of little details that need to be figured out.
Well, if you're, I mean, I can certainly, it would be good for me to get this hardware out of here and ship it off to you, and so if you don't mind, I might do that before I leave for Europe, and
you can certainly go ahead and do that if you've got the end-fed antenna, and then we can talk about it.
I've got all the components. So
I don't have an extra clock to put on it, and I don't
know.
Oh no,
I'll send one with it.
and I don't know. So actually, a good list of all the of what you think the installation would need. Just all the pieces, parts would be good to have on paper. And so that way we can.
I think Nathaniel put together an estimate of the installation for installation costs. I think for a whisper sonde, he came up with like a $1,500 total cost of installation, of a site. But Paul and I don't care about that. We can get repaid next year when the money's become available. So,
well, I think it'd be really interesting, and I think NIST is very interested in doing it, and I was excited to hear that. So it'll move forward. Congratulations, Rob.
Well, thank you. I know we wouldn't be there without your help, Dave. So it's but I think we should, go forward. I mean, you could throw up the whisper sonde at your house or something. It's just to get on air if you wanted to test it all out. So it's even if you don't have much space for an antenna, you'd be surprised. How well it gets out, even with the. And you don't even have to have a resonant antenna on all the bands. I mean, the whisper sonde is amazingly resilient. So.
Well, I was reading the documentation on it from, Turn Island, and the filter set too. Do you have the combined filters and everything?
Yeah, I'll send you the combiner, as well as and all the little jumper cables. I've got it all sitting here. It's not doing me any good. So
Ship it on over. You've got my address.
I do. So I will get it off probably next week. So.
All right, very good.
Okay. I think that concludes our. I can also leave the Zoom open if anyone would like to chat afterwards.
Sure. Hey, John Gibbons,